Next bit. This is a group 3 chemistry. So this is going down group 3. They say nihonium has only recently been discovered. Not possible to measure its atomic radius and melting point because it's too radioactive. Radioactive means they are unstable nucleus, okay? So they have unstable nucleus. They will split into smaller nucleus. So essentially they give off like two elements with lower number of protons and lower number of neutrons. You have done this in your physics course under radioactivity. Yeah. They want you to estimate atomic radius. So you see down the group, you have more filled electronic shells. So you fill more and more electronic shell. Yeah, you get the valence electron feel further and further away from the nucleus. So roughly, I can tell you it's going to be bigger than that because you are filling one extra shell again. If you see from here to here is an increase of around 0.04. I mean, I'm just estimating really, not being exact here. There's no change there. And then there's increase of around 0.02. And then there's an increase of 0.005. So it's quite hard to tell, isn't it? If I were you, I would probably go for the closest one, which is the last change from here to here. So perhaps I could be looking at 0.160. Essentially, it has to be bigger. But how much bigger is up to you. Bigger by this, bigger by this, I don't know. Not really, okay? But I know it will be bigger than this. All right? Why it is difficult to estimate melting point, okay? So melting point is to do with structure and bonding, but here you can see, here they provide you the melting point data. It decrease, so decrease, and then increase. So you see, there's a decrease there, and then it increase again. So that's why you need to use the data from the table to explain. So you cannot just say it's difficult. No, you have to use data from the table. You have to interpret the data. That's what they want you to do. Yeah, okay. So the melting point decreases from boron to gallium, but then showed an increasing trend from gallium to thallium. So this makes it difficult to predict whether the melting point of nihonium, which is that symbol there, so I can just short form it. The melting point of nihonium is going to be higher or lower. It's going to increase or decrease from thallium. Okay? So next bit, boron has a giant covalent structure. So giant covalent structure is the same as what we'll describe as giant molecular structure. So you gotta describe what is involved, what are you breaking that leads to the high melting point. Yeah, so it already give you the structure. So melting boron will involve breaking many strong covalent bonds. Because here they are just talking about the element itself. So we are talking about the boron. Well, okay, maybe I should just skip it just in case. Right, so just breaking many strong covalent bonds, therefore require a lot of energy. Lots of energy. Therefore, high melting point. Okay. Next bit, they're asking you on a group 2 chemistry. They say why they have similar chemical property, okay? In chemistry, we talk about chemical property. We talk about chemical reactivity, okay? Chemical reactivity, it all comes down to your group number and also your period, because it depends on the number of valence electron you have, the number of outer shell electrons you have. Because all the elements in group 2 have 2 outermost electrons. You can use the word outermost, or you can use the word valence. That's the same thing. That refers to outermost electrons. Therefore, they have similar chemical properties. They all will form +2 oxidation state when they form compound. Alright? Now, they say, why is it easier to predict the atomic radius of radium than the melting point? So there are actually 2 factors, because when they compare something, there's one there and there's one there. So you need to address both issue and not just one thing. Okay? Talk about the 2 things. It's only 1 mark, but it is an explanation question. So you want to set yourself out to talk a little bit about something, but not too much into detail, but address both of these points. Yeah. Now look at radium. All right. So look at atomic radius. What do you notice? The atomic radius is down group 2. Yeah. The atomic radius gets bigger. All right. How about melting point? The melting point gets smaller, and then it increases again, and then it gets smaller again. So can you see there is a trend? There's just one general trend. It gets bigger, but here it's quite hard because it decreases and then it increases again. So that's about your skill in reading table, yeah. And can you notice the trend or not? Okay. For atomic radius, there is a general trend. There is a general trend of increasing atomic radius down group 2, but for melting point, we can see it decreases from, so you're stating the obvious really, okay, just using the table and the value in the table, from beryllium to magnesium, and then it increases again, and then it increases again down the group. So no obvious general trend. So therefore it's harder to do the prediction for the melting point because you don't have an obvious general trend. Yeah. Magnesium ion, you want the electronic configuration. Okay, magnesium is in the 3rd period. When you form the ion, it's going to be Mg2+. It's going to have the configuration of neon. All right, and neon has only 8 electrons, so it's just 2 8. We're talking about the ion, which is Mg2+, because they are group 2 metals. They like to lose their 2 outermost electrons and become the noble gas configuration. In the case of Mg2+, there will be the neon configuration, which is 10 electron in the altogether, so it's just 2 8. All right. Question 1. So they say you can use once, more than once, or not at all. So write the symbol for an element. You form a stable ion gaining, so we're looking at a non-metal essentially. So the metal region, they usually like to lose electrons, whereas it's more favorable for the non-metal to like to gain electrons. So you want to gain 3, that is to get up to 8 outer shell electrons. So essentially you're looking at group you're looking at group 5, so there's a Roman numeral there. So group 5 is there. It says use only this element. So the only group 5 element shown there is P, so it's just P, and it says write the symbol. Extracted from hematite, so this is a knowledge-based question. This is iron, so the iron ore that contains iron is called hematite. You might have heard of the word hemoglobin in the red blood cell, so this might have come up in lower secondary science or in your O-level biology. So the heme group in hemoglobin refers to the presence of iron in red blood cell. Heme and heme. Okay, so you can see the similarity there. Forms an ion which give a red-brown precipitate with aqueous ammonia. This red-brown precipitate is iron 3 hydroxide. Okay, it's because ammonia contains OH minus, although it is also partially only in solution to give you OH minus. So we are looking at iron again, because they did say you can use more than once. And this is your typical paper tree kind of thing, which can come out in theory similarly. Chemical properties similar to those of calcium. So we're looking at something that has two outer shell electrons, because when they talk about chemical property that are similar, we're looking at down the group or up the group. So the only group 2, so this is group 2, the only group 2 element here is magnesium, so the answer must be magnesium. Lubricating properties, out of all these, carbon is the one that has lubricating properties, but it's not all form of carbon, it's just one of the few allotropes of carbon, that is graphite. So it's just carbon, it's not, because you're expected to write the symbol, the element for the symbol, sorry, the symbol for the element in the table, so you don't need to specify that it's graphite. So moving on to the next question. Section A is basically answering all the questions. So each chloride may be used once, more than once, or not at all. You want to go for a chloride with cation with a +2 charge. So either you're looking for a transition metal cation, which is +2, or most likely you're looking for a group 2 salt. Okay, so this is a prime example. This is the only one that has got a group 2 calcium there, and it's a calcium chloride, so it's Ca2 plus Cl minus. So that's the formula there. So you can just use the word instead of the formula, because the word, the name in word is already given to you in the list, but you should know the formula by right for all of them. Al3 plus Cl minus. So you know all of the formula that you can get from what you call the valency. You should have done this in year 9. Ammonium ion is NH4 plus Cl minus, so that's NH4Cl. HCl is a covalent molecule. This is iron 3 chloride. Iron 3 refer to iron 3 plus or iron plus 3, then you have Cl minus there. Silver chloride, so silver 1, chloride minus 1, and then plus Cl minus. Next bit of the question, reacts with warm aqueous sodium hydroxide to form a gas. So this is actually a test for ammonium. You will have done this in practical countless of time. You will know that it would definitely be the ammonium chloride, for which if you write the ionic equation, it reacts with a hydroxide to give you ammonia gas, NH2O, which is liquid water. So that is the balanced ionic equation to show the formation of NH3 from reacting hydroxide with ammonium ion. Obviously you need heat, or you need to warm it up. Insoluble in water. Silver chloride is insoluble in water. The rest are not obvious options. So in fact, if you test for chloride, if you think about paper 3, test for chloride, I must say it's not just paper 3 practical component. All the theory paper require you to know all the tests that are listed in paper 3, which you are not given the table in theory papers. Yeah, has a molecule, so we're talking about molecule, has 18 proton, not electron, protons. Out of all this is the only one that is a molecule. So the rest are ionic compounds. They have giant ionic structure. So H has 1 proton, Cl has 17 proton. Altogether you have 18, not electron, you have 18 proton there. So it's hydrogen chloride. Colored solid. So you're looking at colored solid. Out of all these, the iron 3 chloride, transition metal compound. So there's colored there. So property, one of the many property of transition metal is that they form colored compounds.